let's see how to sketch the force polygon and the coupled polygon in the balancing of rotating mass experiment, right? So now we know that we have obtained or we have evaluated, right, the value for the product of mass and the radius of rotation, right, in terms of the number of steel balls, right? You know that, right? And also in the experiment, right, the respected angular positions, right, for the first mass and the second mass, right? Actually the respected angular positions are given, right? The respected angular position for the first mass is 0 degrees, right? And that for the second mass is 120 degrees, right? And the position of the plane of that particular mass, right? Now the position of the plane of the first mass, right, is 17 millimeters, right? Now this 17 millimeters is actually with respect to the equipment, right? Because there is a scale, right, that is actually built in that equipment, right? So this 17 millimeters is actually with respect to the scale of the equipment, right? And the position of the plane of the second mass, right, is 117 millimeters, right, with respect to the scale of the equipment. And so what is the distance between the first and second masses? So that you can very clearly see, that is 100 millimeters. Okay, right. So now let's see how to sketch the force and coupled polygons, right? So first we can actually sketch the force polygon, right? Because now you know actually what is this force. This force is actually the centrifugal force, right? That is given by the centrifugal force, that is given by m omega squared r, right? But finally we divide this value by omega squared such that we obtain the value for the centrifugal force in terms of the product of mass and the radius of rotation, right? That is what we actually refer by m1r1, m2r2 and like that. So now here the angles we are going to measure with respect to the downward vertical. With respect to the downward vertical, right? Let's see how that happens, right? So now first of all and the other thing that we have already obtained by balancing. Here I am not going to explain you the procedure. After balancing the bucket, right, we have obtained the required number of steel balls for the first mass, second, third and fourth mass, right? 80, 81, 72 and 63, right? So now we are going to sketch the force polygon, right? Now what is the first centrifugal force? That is 80. So the reference position is the angles, right? The respected angular position we are going to measure with respect to the downward vertical, right? So what is the first vector? Is 80, right? So this length actually represents 80 number of steel balls, right? Okay, so now this length is measured. Put some dotted line. Now the next angle is 120 degrees. That is actually measured with respect to the downward vertical. So 120 degrees with respect to the downward vertical. So this angle is 120 degrees. Now you got the point, right? So this length, right, which is measured at a position of 120 degrees with respect to the downward vertical, right? So this vector, so let's sketch it like this, right? This vector, I will just write it, I will just sketch it clearly, right? So this vector represents how much? 81. This represents 80 this represents 8100. Now the problem, how can we sketch this one and this one? We don't know the angular positions, right? So what we should do? So just take the compass, right? The next angular position we don't know, right? But if the system is balanced, right, that means if all the centrifugal forces are balanced, right, here we have to obtain a closed polygon, right? Measure the length, right, that represents this value 72 number of steel bolts. Be very careful, these values represent the number of steel bolts, right? Take the compass, right, and measure that particular length that represents 72. Go there, right? So make a kind of a, just make an arc, right? Get the compass, keep it here, make an arc. So what is this radius? That radius represents 72. But this must be a closed polygon, right? So what is the remaining length? 63. Again take the compass, right? Measure that particular length that represents 63. Go there, construct the other arc, right? Now got it, right? So then take the ruler, right? So this is the point of intersection, right? Complete from here to there, then complete from here to here. So now we can measure the respected angular position. So this vector represents the third mass and this vector represents the fourth mass, right? So now how to find the respected angular position of the third mass? Now angles are always measured with respect to the downward vertical. Measure this angle. Again, angles are always measured with respect to the downward vertical. So go there. Again, like every time, if you want to measure that particular angle for the third mass, go to the last point where you have sketched, right? Where you have ended the previous vector. So that means when it comes to the third vector, what is the previous vector? Second vector. So what is the position where the sketching of the second vector is finished? That is over here. So start measuring the angular position of the third vector from where you have stopped in the previous vector. So you can measure this angle. So when it comes to the fourth mass, right? So this vector represents the centrifugal force of the fourth mass, right? So what is the vector that is drawn before that? This one. Then then you can measure the angular position of this one, but be very careful, we have to measure it properly, right? So what is the previous vector? This one, third vector. So where the sketching of third vector has ended? Over here. So this is the point where the sketching of the third vector has ended. Sketch this downward vertical, right? Again start measuring from this downward vertical up to here. So this particular angle represents the angular position for the angular portion of the fourth mass, right? Got it? If it is not clear, so now this part we know, right? From here arc, from here an arc, connect these two, right? When it comes to the third vector, careful, when it comes to the third vector, go to the previous vector, which is the second vector. The sketching of the second vector has been ended from here, right? Or the sketching of the second vector has ended here. Sketch a downward vertical, then start measuring from the downward vertical. When it comes to the fourth vector, go to the previous vector where the sketching has ended. So previous vector is the third vector. Again sketch a downward vertical, then start measuring from the downward vertical, like that, right? So I hope now we got it right. So now from the fourth polygon you can find the other respected angular positions, right? for the third mass and the fourth mass. Right. Now we are going to sketch the coupled polygon in order to find the position of the planes. Right. We are going to find at what particular distance, right, the position of the plane of the third mass is placed. At what particular distance the position of the plane of the fourth mass is placed. Right. For that we are going to sketch the coupled polygon. Right. So let's focus that. Right. So now we know that the couple is given by this equation. Right. The couple will be, we know the centrifugal force. Right. What is that? The product of mass and the radius of rotation. Right. So if you multiply that with the distance to that particular plane, let's call it x, right, mrx, that will give you the couple. Right. So here just consider these four masses. Right. As for now, just consider this is m1, m2, m3 and m4. Right. So these are the four masses. Right. So now here you can see there is a particular distance. There is a particular distance to the plane of that mass, right, measured from the 0th position of the scale of that particular equipment. Right. Right. So here you can see as an example the distance between the planes of these masses. Right. So these masses are positioned, right, with respect to the scale of the equipment. Okay. Right. So like that we know that distance for the first two masses. Right. Now here in the experiment it is mentioned that the distance of the first mass, that means distance to the plane of the first mass is 17 and for the other one is 117, that is 170. So that means now you know the distance between these two masses will be 100, right? Because the reason from here to here 17, from here to here 117. So in between distance is what? What is that? So that is 100, right? So now here when sketching the coupled polygon, we have to consider one position, the position of the plane of one particular mass as the reference, the position of the plane of the first mass as the reference position, right? So then if the first mass is considered as the reference position, right, so then what is the distance to the plane of the first mass from the first mass when it is measured while considering the position of the plane of the first mass as the reference? So that will be 0, right? Because that is the reference, right? Now we know that. So like that, so if you are going to consider the couple of the first mass, that will be m1 r1, let's call it x1, right? m1 r1 x1, right? For m1 and r1 we know that there is a value, right? But x1 is 0 because it is the reference. So the final value will be 0. And when it comes to m2 r2 x2, now we know x2 is 100 millimeters, because the reason, what is the reason? Reason is because x2 is measured with respect to the position of the plane of the first mass. So this must be 100, right? Because m2 r2 you already know, which is 81. So 8100 or 8100, right? So now be very careful. This 81, what is 81? Number of steel bolts. 100 comes from this distance. So let's say this larger value of 8100 is represented by 81 millimeters. So we have to have a very clear idea about the scale. right? So now how to get that? Because now we already know the angular position of the second mass, right? We already know the angular position of the second mass. So from this first polygon we can actually copy that position, right? So the couple M2R2X2 must be parallel to this length, right? So now we know that we don't have to worry about M1, R1 and X1, right? Because the position of the plane of the first mass is considered as the reference, right? So then what about M2R2X2? This we know because the reason we know that X2 is 100 millimeters with respect to the position of the first mass, right? So now carefully focus. Now this vector represents the centrifugal force for the second mass, right? So now without any doubt, right? Now actually here there is no way of sketching M1, R1 and X1 because you know that it is 0, right? So it will be just like a dot, right? Okay, so we don't have to worry about that. Okay, so now we can focus, right, sketching on the vector that represents M2, R2, X2, right? Now M2, R2 is 81, X2 is 100, so it will be 8100. So let's represent it by 81 millimeters. Okay, you can use a higher scale, right, as required, right? So M2, R2, X2 will be 81. So let's sketch that parallel to this vector, right? Okay, right? Okay, be very careful when you are going to sketch these things. You need the set square and a ruler, right? And here it must be parallel, right? Okay, let's sketch it like that, right? So this represents 8100 by 81 millimeter length, right? Okay, so now how about the other one, right? Here also we should include the directions, okay, right? Down towards here, here and here, right? Okay, so now the next vector is M3, R3, X3, but unfortunately we don't know what is this X3, right? But one thing is sure that it must be parallel to this one, okay? So use another ruler, right? That will be a support in order to project, right? So this vector represents, now actually from this vector we can get the direction of M3, R3, X3, right? But there is a doubt, we don't know whether it, right? So we don't know whether it, now see, we don't know whether it goes towards the upward direction or downward direction, right? Anyhow, this vector must be parallel to this one. Maybe from here towards the upward direction or downward, but we don't know. Other thing, now anyhow, the polygon, the couple polygon must get what? Completed, right? So that means definitely now what is the remaining vector? The remaining vector is M4 R4 X4, right? And another one thing is clear, that this couple vector must be parallel to this one, right? Because from this first polygon we know the angular position, right? So anyhow this polygon should get completed, right? Now if this polygon is completed, now don't worry about the ending portion, right? Because if you are going to start sketching the third vector, which is M3 R3 X3, from here it will either go towards the upper direction or downward direction, right? If it goes towards the upper direction, the ending point for the third vector will be here. If it goes towards the downward direction, the ending point will be here. Now don't worry about that. Now just focus the fourth vector. Anyhow the polygon must get completed, right? So use the tools. It must be parallel to this vector and it should pass through this point in order to complete the polygon, right? So now we know that. Now we got it. So that means the only possible way is, right? Now see, just sketch the vector for M4 R4 X4, right? In such a way that it is actually it must be parallel to this vector, right? So trace it. Now you know this is the only possible way, right? Right? I hope you got it right. Yeah, I am just sketching it, right? So this is the only possible way. Okay? Right? No any other way. Okay? Let me sketch it again. It's not straight, right? Shall I sketch it again? Because now we know that after projecting this, there can't be any other direction, right? We cannot sketch this vector in such a way that it is parallel to this vector, right? In such a way that it will ultimately complete the polygon. So this is the only possible way, right? So as it is not clear, I will sketch it again. So it's not that much large, okay? Somewhat like this, right? Okay, so now you can measure the length, right? Okay, it is parallel to this one, right? And this one parallel to this one, right? Okay, because now we know the scale, right? Because we know that if you are going to consider this vector, this 81 millimeter line represents 8100, right? So just measure this length, right? Just measure this length. So just measure this length in millimeters, right? Right? So now say for an example, if this length is let's say 30 millimeters, right? Let's say that length is 30 millimeters, right? So that means multiply that by 100. That means 3000, right? So divide 3000 by number of bolts, 72. So then you will be getting that required distance in millimeters, right? Understand, right? For the other one, now let's say for example, this length is let's say 95 millimeters, right? Let's say this length is 95 millimeters. So 95 millimeters means the couple must be 9500, right? So divide that by number of bolts, 63. So you will be getting the answer in millimeters. That means the distance to that particular plane, right? That's how you